Hello, and welcome to this video presentation. My name is Paul Brett. I'm a Senior Software Support Analyst supporting the Transformation Extender product from IBM. The topic for this video is data conversions and Byte-Order-Marks. Feel free to reach out to me on popular social media channels at Paul Brett IBM. I'm going to start this demonstration, as usual, in the Design Studio. I have one project, Encoding BOM. Within that project I have one map called example.mms. I have a couple of input files, and I have a utility Typetree. Let's open the map source file and see what we have. In the map source file I have two executable maps. One is called test1. In test1 we have an input card and we have an output card. Each card is reading a simple text blob object. On the input side we have defined this text blob object to be UTF16 Little Endian. On the output side we have UTF16 Big Endian. Now let's open our input file within the Design Studio, and as you can see it just says the word hello. But the editor in the Design Studio is not telling you the full story. If we open the File Explorer at the same directory and open the input.txt file in Notepad, it also says hello, but again still not telling you the full story. If I open it up with UltraEdit, my hex editor of choice, and go into hex mode, you can see that the hello is encoded as a sequence of 10 bytes starting with 48 null, 65 null, 6C null, 6C null again for the two L's, and then finally 6F null. The first two bytes of the file, FF and FE, are the byte order mark. It tells the various editors that this is UTF16 Little Endian. When we build and run this map, the file is written, the file is output.txt. Opening it up in the Eclipse Map Designer, we see that the word says hello still, but again not showing the full story. Within Notepad, output says hello, but let's look at that with UltraEdit. Now you will see that the sequence of 10 bytes that makes up the word hello is null 48, null 65, a pair of null 6C and null 6F. You'll notice that the null is before the actual byte, and the encoding bytes at the beginning, the byte order mark, is now also opposite, FE, FF, instead of FF, FE. So this file is denoted as being UTF16 Big Endian. So the map has done its job properly. Now my input file had a byte order mark, and the swapping of the two bytes is what the Typetree does, and therefore creates the correct byte order mark on output. So what do we do for a file that doesn't have a byte order mark to begin with, but we need one on output? Let's move to example test2. In the test2 map, on the input side I'm reading an alternate input file. I'm reading input ASCII.txt instead of input. On the output side I'm still writing to UTF16 Big Endian. On the input side, I'm just reading the file in as native, so on this platform it will be read in as US ASCII. Let's have a quick look at my input file. In the Eclipse Designer, it just shows us the word hello, but let's see the full picture and open up the file in UltraEdit. Switch to hex mode, and as you can see, this is a very simple file. It is just encoded as US ASCII. 5 bytes. 48, 65, 6C, 6C, 6F. So there's nothing complicated about the input. When I build and run this map, build, run, now the output file, when shown in UltraEdit, has the null and the byte to make it UTF16 Big Endian. I have 10 bytes here, but the thing that you'll notice that is missing is the byte order mark. With the byte order mark missing, if I try to open this up in Notepad, you will see that Notepad makes a complete mess of it, as it thinks the nulls are actually part of the data and therefore converts them to spaces. Okay, there are two ways around this. The first way is to use a mapping rule. I'm going to copy test 2 as test 3, and within test 3 I'm going to copy the output card 1 and copy it as output card 2. Okay, output card 1 I'm going to change so that this no longer writes a file, change it to sync. And output 2 I'm going to change the type tree, not to use UTF16 Big Endian, but instead just native. So in out 2 I'm going to read the content of out 1, but encapsulated within a C text function. What this does is it says, don't do any conversions, just take the stream of bytes as is and assume that it is the character set that I mention. And in my case, I'm going to read out and I'm going to say it's already native. Don't do any conversions to it. I'm saying it's already native and I'm reading into an object that is native. So there will be no conversions that take place. And then I'm going to add on the byte order mark at the beginning. I'm going to do that with a concatenate of a fixed text string, FE, FF. I'm going to use the symbols to put in direct bytes of FEFF for Unicode Big Endian. If I now build and run this map, you'll note that the output file in UltraEdit shows that I have the correct sequence of bytes and the correct byte order mark, and if I double click on it in Notepad it opens up correctly. Here's another little trick you can use. In the file save as, it will tell you the encoding that it read the file as in this encoding box. If this encoding box isn't visible, it could be because this section is hidden. Okay, so that's one way of doing it, using a rule. There is another way of doing this, and that's with a type tree change. So if we go back to test 2 and copy this as test 4, and within test 4, instead of using this type tree, UTF16 BE, I'm going to use a different object within that type tree. And this time I'm going to use UTF16 BE underscore BOM. I'm going to show you the properties of that object. It's still UTF16 Big Endian, but if you have a look at the type syntax, I have added an initiator to this object. And in literal, I've put in the byte order mark as 2 literal bytes, FE and FF. Now if I build and run this map, before I do that I'm just going to delete the output file just to show it getting recreated. Build and run, map is completed successfully, and if we double click on it to open in Notepad, it looks normal, and if we look at it with UltraEdit, it's the full 12 bytes that we expect, including the byte order mark. So there we go, 2 ways of adding the byte order mark when your input does not contain it, one using the map and the other using a type tree property. I want to thank you for taking the time to watch my video presentation today. If you found the content interesting and informative, please hit that like button, perhaps leave a comment. Consider subscribing to my YouTube channel as I release content such as this on a regular basis. Feel free to reach out to me on popular social media channels at Paul Brett IBM. Thank you.